Returning to calculus. Now remember, we've talked about the derivative, and basically it's a rate of change, measures a rate of change. We're now going to look at the specific application of drawing our curves, because we know how to sketch good basic curves, but this now gives us more information when we use our ideas from calculus. So let's look back at the first derivative and a reminder of all the different notations that we could use and see. So y dash f dash x, d dx of the actual function, probably the most common of them all, the y dx. When we talk about curve sketching, the rate of change of the curve is basically the slope of the curve, rise over run if you like. Now what we can tell from that is, well, if the first derivative is positive, that means our tangent has a positive slope. So if you think about the curve, if it's got a positive slope, the curve must be going up or increasing. So logically, if it's less than 0, it must be decreasing. And that gives us the third possibility. If it's 0, then it's not going up, it's not going down, so we just say, well, it's stationary at that point. So just using the first derivative, we can draw a pretty good sketch. So we're going to find all of these stationary points, determine their nature. So what type of stationary point is it? And then we'll go and actually draw it. Well, let's find the derivative. There it is, 6x minus 3x squared. Write this sort of stuff down. Explain your solution. Don't just go and solve it. Remember, someone is reading your solution. They want to understand what you're doing. So you're writing down, well, I know stationary points occur when that first derivative is equal to 0. So therefore, I'm going to solve this equation. So you're explaining where it's coming from. You haven't just pulled it out of thin air. There is some logic behind me solving this equation. It's a simple little one to solve. We get x equals 0 or x equals 2. So we know we have two stationary points. Of course, I need a y value to complete what the point is. So 0, 0 and 2, 4. But be careful. Make sure you substitute into the function and not the derivative. Because if you substitute in the derivative, obviously you're going to get the answer 0, because we just found they were stationary points, and they're not x-intercepts, they will be at other points. Determine their nature, but remember we're only using the first derivative at this stage. So let's have a look at this point 0, 0, and I'll draw myself up a table of values. So 0 is the point I'm interested in, and I know at that point it's stationary. So the derivative is 0. I'm just going to draw myself a horizontal line to remind myself. That means the tangent is horizontal. Now what I need to do is check either side of the point and let's see what's happening. So I've got to pick a point on the negative side of 0 and a point on the positive side of 0. Now I can pick any number I like, so long as I don't go past another stationary point or any point of discontinuity. So I can pick any number I want. So on the left-hand side, I'm going to choose -1. 1's always an easy number to work with. And I get -9. It's going down. So again, I'll just draw myself a line there to go, right, it's going down. On the right-hand side, I'll choose +1. And I get 3, it's going up. Now, my little diagram of the tangents there shows me clearly what the curve's doing. It's going down, stationary going up. So it must be a minimum turning point. And when you draw the table of values, don't just draw the line. It's very tempting to do that, of course, because when you look at the coordinates, you kind of know this is going to be a minimum. So it's very tempting to just go, oh yeah, and it looks like you've done all the work and you haven't really. They want to see your substitution. So write down the value you're substituting in and write down what the answer is as well. Okay, let's have a look at 2, 4. So we know 2 is a stationary point. I've got to pick a point on the left-hand side or the negative side, point on the right-hand side or the positive side. Well, I'm not going to make any extra work for myself because I can still use 1, which I used in the one before, and we know that one. So let's now just pick a point bigger than 2. What did I go for? 3. Sub it in, I get -9, and I can now see this curve's go, it's going up, stationary, going down, got to be a maximum turning point. So from that, I can draw a very rough sketch. I'm not going to bother finding x-intercepts at this stage or all that sort of stuff. I know it goes through the origin, however, because the y-intercept is 0. And there's 2, 4, the maximum. So if I draw it in, as I say, very rough sketch. But at least it gives me an idea of what the curve's doing, when it's positive, when it's negative, things like that. That'll do us for now. So we're just using the first derivative at this stage.